section 2.3, we're going to be discussing functions and relations. This is really a big vocabulary lesson. There's really not a lot of math, at least computation, to do. But we are going to be discussing a couple of topics that seemingly give a number of students difficulty when I ask you to explain what they are or how to find them. So in this tutorial, we're going to attempt to try to make sense of some of these words like domain and range, function, relation, what does it mean to be one-to-one, different things like that. Not going to be too wordy about this. There's a lot of words on the screen. I do intend that you be able to print this out or at least have it on your screen in order for you to kind of read through it. I am going to talk about, I'm not going to discuss all, this is a snapshot of the vocabulary from your book, but I'm not really going to discuss all the different vocabulary words. I've picked a couple of them out that I thought were maybe a little bit more important, that we really have a really good grasp, a deeper understanding. The first one we're going to discuss today is domain. Now, domain, let me kind of limit our view here. The domain of a problem is really going to be limited to what we would call the inputs. This is going to be the numbers that I can plug into my equation. For example, we have y equals 3x minus 5. The question is, what's the domain for that function or for that equation? Sometimes it's easier for us to ask not what can I use, but what can't be used. Maybe everything except for just a small number can be used, or maybe everything can be used. And so we have to ask ourselves, if I look at the equation y equals 3x minus 5, what numbers would give me a problem? If I plug it in, what numbers are going to give me something that says undefined? Or in my calculator, I would get something like an error. And if you look at this one, you're thinking, well, I can't think of anything that doesn't work. I could plug in -1, I could plug in 1/2, I could plug in 0, I can plug in +1, I can plug in 1,000, 1,000,000, -1,000,000. There seems to be no limit to what I can plug in. Well, that's good, because there is no limit. In this case, we always talk about when every number can be used, we always say it's all real numbers. 1 have a domain of all real numbers. The one line that doesn't have a domain of all real numbers is a vertical line. And the domain for those depend on what vertical line you have. It's just 1x, and it's whatever the number is. X equals 5. Well, guess what? Your domain is 5. And then we're going to look at a couple of other expressions. What happens when you have something that doesn't work? So there are two main types of equations that we have to be careful about. We're going to look at one of those today. What happens when you have a fraction and we have an x in the bottom of the fraction? Well, let's go back to our question. What numbers cannot be used? Well, if you know anything about fractions, you cannot divide by 0, or we cannot have a 0 in the bottom of my denominator, or in the bottom of the fraction. Right? So if that's true, then we want to know this question. What makes that part become 0? So we do this. We set the bottom equal to 0. X minus 1 equals 0. And so it's clear that if I plug in a +1, so x equals 1, makes the bottom become 0, and that's not allowed. That would give me error or undefined, or your calculator would give you error, real or non-real answer, or something like that. And so what we do is we say that, okay, every number works, except for the 1 or the 2 or however many you work it out to be. This one's a simple one. There's only one number that I can't use, and it can't use the number 1. So we say it's all the numbers that work except for 1, or we can use the symbol all real numbers, and we just say, well, except for, and we use the x is not equal to 1. So I tell you what does work, and that's the symbol all real numbers, and then I tell you what can't work by giving you a restriction, or what we call restricted values. Let's talk about domain. We just got through talking about domain. Let's talk about range. This one's a little bit more difficult to to figure out. There's not a magic formula that where, like last time, if I had a fraction, I could set the bottom equal to 0 and solve. The range is exactly the opposite of the domain. If the domain is the inputs, then the range is the outputs, what comes out of the equation. So it's a little more difficult to describe. The best way to look at a range, or look at the range of a function or a relation in general, is to look at the graph. Now sometimes it's easy to tell, but there's a couple of questions you can ask if you can't look at the graph. Let's suppose we had a parabola. Well, all parabolas have either a minimum or a maximum depending on if it opens up or if it opens down. And so let's just take a basic parabola, y equals x squared, a traditional one. Well, then we know that that minimum value, we know the vertex is 0, 0. So we know that the smallest y value in that on that graph would be the origin. Nothing goes below the origin in that picture, but it goes up forever. So we can say the range of that particular one would be y is greater than or equal to 0. It's all the numbers bigger than and including 0 for y. So always look at your equation or your graph if you can, or ask the questions, does it have a minimum or maximum? Okay, if it has a minimum, then I'm going to have a greater than or equal to or greater than scenario. If it's a maximum, it's going to be a less than. Let's talk about functions and relations. A relation, it's really just what it sounds like. It's describing a relationship that exists between variables. And the variables we're using are x and y. Look at the one we have here in bold. It says y equals x plus 1. If I were to describe that relationship to you, then I would tell you that, well, the y value is always going to be 1 more than the x. And if we were to plug in a couple of numbers, you would get results like you see on the screen. I'd have the values 1, 2, 4, 5, negative 4, negative 3. Remember that negative values are upside down because more negative is smaller. Okay, relationship a little bit more specific than just any generic function, or relation out there. We can determine if something's a function by doing a very, very easy test. We call that the vertical line test. The vertical line test, basically, if I were to draw my function or graph it, and if the graph, and you'll see a picture of it in just a little bit, if I can draw my vertical line and it only touches the graph one time, and I look for a place that, well, maybe it touches twice, but if it never touches it twice, then it passes the vertical line test because it only touched it one time. That's not supposed to happen. There we go. It only touches it one time, so that makes it a function. If it passes through it more than once, okay, then that relation is not a function. And there's no special description of it. It's just not a function. Okay, something to note, interestingly enough, your calculators, if you're using a TI-83 or 84 like we have in class, you can't graph a non-function. For example, a non-function would be a y squared equals x. Well, you're not going to be able to graph that. In fact, you won't even be able to type it into the calculator. So something to look out for is if you do have something in that situation, you may not have a function if you can't graph it. All right, last topic is one-to-one. If you go back to the beginning, relations cover everything. Okay? Well, some relations are special. Okay? They're called functions. And then if we break it down even further, some functions are very special. And these are called one-to-one. So I've written a couple of points here for you. If I have a function, okay, if I'm looking to try to see if it's one-to-one, and these are 2 points on my function, I have 1 and 2, and then negative 1 and 2. Notice they have the same y value, but different x's. Remember that if the x's are different, then it's good as a function, because that's what I want to make sure. There's no repeated x values. but here my y value is repeated. Well, that's okay for a function. Y values can repeat in functions. Y values are different. So we say that if it's 1-to-1, if the x's all have one single y value for each one. And so we're going to kind of close this up by looking at 1-to-1 and functions as vertical and horizontal line tests. Notice I said example here, y equals x squared is a 1-to-1, is a function, excuse me, but it's not 1-to-1. Look at the picture. It passes our vertical line test. No matter where you draw that vertical line, it's going to only go through one time, right here or here or here, any of these places. But if I were to take the horizontal line and draw it through my parabola, I do not get single point. I actually have two places on my function as it goes through the line. So this fails the horizontal line test. Therefore, it's not 1-to-1. Okay. If we go over to x cubed, okay, clearly passes the horizontal or the vertical line test. No matter where I drag that horizontal or that vertical line, it's only going to go through one time. But if I take my horizontal line, I start it down here. Now you may think, oh look, that's horizontal in the middle. Actually, if you zoom in really close, you'll find out it's not horizontal ever. Okay, it just appears to be from as far out as we are here. Notice that's 400. So we've zoomed out quite a bit. This function is also 1-to-1 because it only touches the line one time in its horizontal line test. Okay, so remember, vertical line test tells me if a relation is a function. If it's a function, if it's not a function, it's definitely not going to be 1-to-1 too, because a 1-to-1 graph is also a function. So if it's a function, it passes the vertical line test. I check the horizontal line test. If it passes that one, then it's also 1-to-1. Okay, this covers most of the content from section 2.3. It's a lot to talk about. Print this out, go through it, highlight the different pieces, and the tests, that's kind of what you really want to make sure of, that you can identify. Is it function? Is it a 1-to-1? What's the domain and what's the range of values? We're going to talk more about those in class, but make sure that you have that kind of knowledge, that vocabulary down.